Hello, everyone. My name is Donovan Gregory, and I'm here to talk to you a little bit about what I've learned on my journey through machine learning, which is what my project has been upon these last 2 semesters. Earlier this semester, my partner talked a bit about the algorithms that we are using for our neural network, which is the machine learning type that we went forward with for our project. But since he already talked about that, I'm going to go back and talk a bit about all the stuff that I've learned in general about machine learning since then. Because when I first went into this project, I was fairly limited in knowledge. The only language is that I had any clue did anything with any sort of AI or machine learning or data mining or any of that stuff was Python and Lisp. And I had no particular desire to work in Lisp. I'm not very good with it. So I had decided that Python was going to be the language I was going to be programming in. Since then, I've learned that there's actually a couple of different languages that people write machine learning code in. The first and most popular is Python. One of the reasons that is because there's so much support for it. There's a lot of libraries that have been created to help with machine learning. It's also a very simple language, relatively easy to use. And so, in general, it has been the most popular. The next one after it is surprising to me, at least, Java. I haven't used Java too much, so I wasn't aware of everything you could really do in that language, but it's really popular. And then the next most popular is R. And R is a language that really is designed almost for machine learning. It's not its only use. It's actually used for a variety of statistical and graphical techniques. You can read more about it on the Wikipedia page. But it's an interpreted language, which is interesting. Command line. And so you do it, you write the code line by line, which has been an interesting way of working on problems. I started taking the machine learning class on campus, and so I was introduced to R. And it would have been an interesting approach to my problem, or what I was trying to accomplish with the program being able to figure out letters based off of various variables. I will say that if you ever do decide to use R, you really should make something called RStudio. It's a great program for being able to work in R, and it just helps you visualize things a lot better. It lets you see the different variables you've created and just things like that. It's the way to go if you're going to do this kind of work in R. Also in the class and through my studies, I've learned that there's quite a few different ways to approach machine learning. The neural network that we're creating is just one of many. From my research, it seems, generally speaking, on complicated problems like this, it can be one of the more accurate approaches. However, it is definitely not the only one. For instance, there is classification and regression trees. And they're represented as binary trees. It makes a decision and goes on one side of the tree or the other, as you can see in that little example. Um, it works fairly well. From my experiments in my machine learning class, it wasn't the most accurate, but generally speaking, in certain data sets, it works really well. Um, Another one is K-nearest neighbor. This particular approach is based off of the basically it classifies them based on the variables that are around that are most similar to based off of its quote unquote neighbors. Um, I will not claim to be an expert on this particular subject. I didn't spend much time with K-nearest neighbor, but I know that it's an important enough one that we learned about it in class. Another one that I learned about that was really interesting is the naive Bayes model. It's based off of probability and stuff like that. And it actually works really well for a lot of companies. They found that despite the naive assumptions that the algorithm makes, it still is within a reasonable amount of error, that it's worth it because of how simple and easy it is to run. The naive part of the algorithm is that the algorithm assumes that every element is independent of each other. So there's no there's no reliance on different elements. So if one thing affects one, it only affects that one. It doesn't affect another one. Which, as you can imagine, for certain scenarios, kind of can ruin the whole thing. And so it was interesting to me that this was widely used. But if it falls within reasonable error, I guess that's fine. And that really is the biggest things that I've been learning about, just the different types of algorithms, and there's a lot more out there. All of these fall within the idea of nonlinear algorithms. And that's not even the tip of the iceberg. You can get into deep learning, and there's also the linear algorithms to look at. There's just a lot of information out there, a lot of places to study. And it's definitely a growing field. And it looks really good to be able to understand and communicate about it. So, thank you very much for your time. I hope that you learned something in this video that you might be able to find more interest in. Again, thank you for your time.